All right, good morning. Today, for pre-calculus, I'm going to be covering evaluating trig functions, trig function values using reference angles, excuse me. So the couple things as I want to go over here to this chart, which shows us that where the sine, cosine, and tangent are positive and negative. We've gone through this before. Remember, if I look at any point in that graph, this could be a point, right? That could be maybe 2, 1 on the in the first quadrant, and the cosine is the x coordinate, and the sine is the y coordinate. It goes alphabetical, and of course the tangent is what I get when I divide sine by cosine, or y divided by x. So positive divided by positive is positive. You can figure it out that way, or you can just memorize them, which is encouraged as well. So now that we've gone through that again, with these, if I we're given an angle. In this case, it's 240 degrees, and in this section, the directions are no calculator. Find the sine, cosine, and tangent of the following. So if I'm given 240 degrees, I'm going to draw this in standard position, which means I'm going around the circle. You always start over here at the x-axis and go that way if it's positive. If it's a negative angle, you go the other direction, but you still start at the same place. So 180 would be halfway around, 270 is 3/4 of the way around, so 240 is in between somewhere. So I go around there. And then I need to find out what the reference angle is. And the reference angle will be that between the 240 degree line and the x-axis. Remember, the reference angle always goes to the x-axis. So if I subtract 240 and 180, I get my reference angle, which in this case is 60. Okay. So that's my reference angle. And since it's a 60-degree angle, I can tell you already, if I go back up to my little chart up here, since I'm in the third quadrant, I know the sine is negative, cosine is negative, and tangent is positive. Okay, that's quadrant 3. Here's 4. Remember, quadrant 1, quadrant 2. Okay, all right. So negative, negative, positive. So I'm just going to fill those in so I don't forget. Now, since it's 60-degree reference angle, we're back to the 30, 60, 90. Sine would be the opposite over the hypotenuse, which would be 60 degrees, not 30 degrees. Got the wrong one. So opposite the 60 degrees is the square root of 3 and the 2. So that's the sine. Cosine would be the adjacent over the hypotenuse, which would give me 1 over 2. And the tangent would give me square root of 3 over 1, which is square root of 3. So those are my answers. Next one, same directions, 330 degrees. So going all the way around the circle would give me 360 degrees, which means I'm going to come up a little short. In fact, if this is 360 and this is 330, if I subtract them, you get 30-degree reference angle. Now, since I'm in the fourth quadrant, the sine will be negative, cosine will be positive, and the tangent will be negative. So reference angle is 30, so I go back to my triangle. Sine is opposite, that's the opposite of the 30. There's the hypotenuse of 2. Cosine of 30 is square root of 3 over 2. And tangent would be negative 1 over the square root of 3. Okay. Tangent's opposite over adjacent. Okay, so moving right along. Next one, same idea, 135. So if this is 180 degrees, we'll be halfway around the circle. So 135 is before that. This would be 90, which means my reference angle, which will be here, would be 180 minus 135, which will give me 45 degrees. So my reference angle is 45. And now I go back to that triangle, the 45, 45, 90. Wait, which quadrant am I in? Let me do that first. I find if I mark in the positives and negatives right away, I don't forget. That's the easiest thing to do. So in the second quadrant, the sine is positive, cosine is negative, and tangent is negative. And if I go to the 45, 45, 90, sine would be 1 over the square root of 2. 1 is opposite the 45. Square root of 2 is the hypotenuse. And if you fill those values in, cosine's the same thing except negative, but the tangent will be -1. All right. This one, a little more straightforward, not finding all of them, just asking what's the cosine of 150 degrees. So here's 180, here's 90, which means if I go to 150, my reference angle goes to the x-axis, will be 30. So 30-degree reference angle. Cosine in the second quadrant is negative. And if I look at my 30, 60, 90 triangle, the cosine would be the adjacent over the hypotenuse. Adjacent from the 30 is the square root of 3. So it's square root of 3 over 2. And that's my answer. Next one, sine of 300. So 300 is in the fourth quadrant, almost all the way around, right? 360 would be once around the circle, which means my reference angle will be 60 degrees, which I get by subtracting those. So the sine is negative in the fourth quadrant. And if I go to my special right triangle and look for what is the sine of 60, you will get square root of 3 over 2. So this will be negative square root of 3 over 2 since it's in the fourth quadrant. Number 6, tangent of 240. So here's 180, here's 270, so 240 is between those two. And if I subtract 240 and 180, I'll get my reference angle, which would be 60. So my reference angle is 60. My tangent, if I go back up to my chart up here, the tangent is positive in the third quadrant. So I know my answer is going to be positive. And if you draw out the triangle, I guess. Here's 60, 90, 1, 2, square root of 3. So I am looking for the tangent of 60, which gives me the square root of 3 over 1, or just the square root of 3. And that's my answer. Next one. Find the sine, cosine, and tangent of the following. No calculator. All right, so I'm going to start out with 7 pi. So if I take, if I go all the way around the circle once, that's 2 pi. So if I went around the circle twice, that would be 4 pi. And if I went around the circle 3 times, that would be 6 pi. So if I went around 1, 2, is that 2? Yeah, 1 more is 3. And then I go 1 more, I land over here at 1 pi or 7 pi. It would be the same thing. So this is coordinates kind of thing. So remember your unit circle. If I am over here, this is the coordinates -1, 0, which means the cosine is the x-coordinate and the sine is the y, and if I divide those two, I'll get my tangent. So the sine will be the y-coordinate, which is 0. Cosine is the x-coordinate, which is -1, and sine tangent will be y over x, which is 0 over -1, which is 0. Okay, so next one, 5 pi over 2. So 4 pi over 2 would be 2 pi, which would go all the way around the circle. So this is another half pi. So that would be 1.5 around. So that's up here. So once again, this is going to be another unit circle kind. Coordinates up here would be 0, 1. So again, my cosine is the x, sine is the y. So the sine will be 1, cosine will be 0, and tangent will be y over x, which is 1 over 0, which is undefined. Okay, so those are my answers. Next one. Negative angle, good. So we're going the other direction this time. I still start at the x-axis, but this time I'm going clockwise instead of counterclockwise. Let's see, 6 pi over 3 would be 2 pi, which would be once around. So I go all the way around the circle once, and then a little bit more. 1 pi over 3 more. So that is what this is looking like. And so which means my reference angle in here is going to be pi over 3. And pi over 3 is the same as 60 degrees. Which means, so let's see. So before I get to the actual numbers here, let's figure out positives and negatives. Sine is negative in the fourth quadrant, cosine is positive in the fourth quadrant, and tangent is negative. So before I forget those. So now that I've done that, now I can go back over here and I just treat this like a regular 30, 60, 90 triangle. So this is 1, 2, square root of 3. So the sine is the opposite over the hypotenuse, which is 1/2. Cosine is the adjacent over the hypotenuse. I messed that one up. It should have been the square root of 3. Square root of 3 over 2. Square root of 3 is opposite to 60. I was looking at the 30 for some reason. Okay, cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. So those are your answers. Next one. Solve for theta. Theta is between 0 and 360, as it says there in compound inequality. So the sine of theta equals the square root of 3 over 2. Now I'm going to have two answers here, okay? So I know that the sine is positive here and here. So if I go back to my triangle for a minute, that 30, 60, 90 triangle again. It's 1, 2, square root of 3. My reference angle for sine is opposite over hypotenuse. So which angle is opposite the square root of 3? That would be the 60. So 60 degrees is my reference angle. Which means I got two answers here. Here's going to be the first one. Here's going to be the second one. So remember, this is going to be 60, and this is going to be 60. So that's my first one, which is really straightforward. It's just 60. The second one, though, is going to be starting at the x-axis and going over to that line there, which would be 180 minus 60 or 90 plus 30. Either way, you get 120 degrees. And those are your two answers. Next one, same directions. Sine of theta equals negative square root of 2 over 2. Okay, one thing quickly, I recognize this being the same as that, okay? So if I took 1 over the square root of 2 and I multiplied it by square root of 2 over square root of 2, I would get square root of 2 over 2. So these are actually the same thing, assuming that we made it negative. So I'm looking at that. What is the sine? What's the angle? That gives me 1 over the square root of 2. And if you do that correctly, your reference angle will be 45. Which means if I go over here and now where is the, what's that, the sine is negative here and here, which means I'm going to have two angles. This one's 45 and this one's 45. And what are those two numbers going to be? This one goes past 180 and then another 45, which gives me 225. The other one is almost all the way around the circle, except you come up 45 degrees short, which means you go 360 minus 45, which gives me 315. And those are my two answers. Okay, next one, number 12. Same thing, right? Negative square root of 2 over 2 is the same as 1 over the square root of 2, okay? Which means that my reference angle is going to be 45 degrees, because that would be the triangle right there, right? 1 over the square root of 2. Forget the negative part. When you're looking at that, it's just what's the angle. 1 in the square root of 2 would give you 45. Okay, now the cosine, which quadrants are the cosine negative in? So the cosine is negative here and here. So that's where my two reference angles will go. This is 45, this is 45. My answers will be, you know, if you start at the x-axis and go over there, so that's 180 minus 45, which is 135. And the other one will be, if I start over here and go all the way around to there, past 180, and add 45 gives me 225. And those are my answers. 13. Tangent of theta equals negative square root of 3. Okay, so let's see. Tangent is negative here and here. Look back at your chart. So I know those will be the quadrants where my reference angles will go. Question is, what is it? So I see that square root of 3a, so I'm thinking maybe 30, 60, 90. And if you look at it, so the reference angle, so tangent is opposite over adjacent. So which angle is opposite the square root of 3? That would be the 60. So 60 degrees is my reference, which means these two numbers are 60, and I can now figure out what my answers are. So once again, start at the x-axis. So that one would be 120. The other one's almost all the way around, but you stop 60 degrees short, which would be 300. And those are my two answers. Oops. Next one. Cosine square root of 3 over 2, and it's negative. So let's see, which quadrants is the cosine negative in? That would be these two, 2 and 3. And cosine is adjacent over hypotenuse. So which angle's adjacent to the square root of 3? Which angle's adjacent to the square root of 3? That would be the 30. So 30 degrees is my reference. Which means This is 30. This is 30. So that'll be my first answer, which would be 180 minus 30, which is 150. The other one would be past the 180 by 30. So 180 plus 30 is 210. And those are my two answers. That's number 14. 15. Cosecant. All right, so like I've said so many times, I don't usually work with cosecant. I like to switch it to the other function. The sine is the inverse of the cosecant. So if I put that over 1 and then flip it upside down, I get negative 1/2. And now this is remarkably like several of the problems we've already done. So the sine is negative here and here. Second and third quadrants. So those are where my two reference angles will be. Oops, I made a mistake. Sine's negative there, 3 and 4. Okay. So forget the negative for a minute. Which on my 30, 60, 90 triangle gives you the reference angle of the opposite the 1 and the 2 being the hypotenuse. And if you look at that quickly, you would find out that the reference angle would be 30. Where's that triangle? There it is. So yeah, the 30 opposite the 1. So this is 30, this is 30, and then we've got to figure out, starting at the x-axis, how many degrees is each. That's 180 plus 30, which is 210. And the other one's almost all the way around, but 30 degrees short, which is 330 degrees. And those are your two answers. Cotangent. So once again, I'm going to switch it to the inverse function, which would be the tangent. Flip this upside down. And now I'm going to look at which quadrants the tangent is negative in. And if you look back at your chart, then tangent is negative here and here in 2 and 4. So that's where my reference angles will be. Now, what's the reference angle? Remember, tangent's opposite over the adjacent. Which means, which one's opposite the 1? That's the 30. So 30 degrees is my reference. So this is 30, always to the x-axis with that. So how much is that? We'll give you 180 minus 30, which is 150. And the other one would be 330, because you go almost all the way around, but come up 30 degrees short. 360 minus 30. Those are the answers. $17. This one's tricky. So if I flip it upside down, right, and I work with the cosine, because the secant and cosine are inverse, and I get 2 square roots of 3 here. Now I want to get rid of that radical in the bottom of the fraction. So in order to do that, I'm going to multiply top and bottom by square root of 3 over the square root of 3. And what I get is I get 3 square roots of 3 over square root of 3 times square root of 3 is 3, and 3 times 2 is 6. And then I can reduce that, which gives me 3/6 is 1/2. So square root of 3 over 2. So that's actually what I'm working with here, is I'm looking at the cosine of theta equals negative square root of 3 over 2. Okay, lost a negative sign there, but it's still there. Okay, so cosine is negative in the second and the third quadrant. A momentary lapse there, so that's where my reference angles will be. And then I need to figure out what is the actual reference angle. If I'm looking at the 30, 60, 90 triangle, square root of 3 over 2 with cosine. So which one's adjacent to the square root of 3? 30 degrees will be my reference angle. So then this is 30, this is 30. And if I figure out how much that is, that's 150. That one will be 180 plus 30 is 210. Those are my two answers. All right, so I got two more problems for review here. Given that the secant is -7 square roots of 3 and theta is in quadrant 3, find the sine of theta. Okay, so I need to find the rest of the triangle, okay? So I'm going to draw a quick triangle. Now secant and cosine are inverses, so the cosine of theta will be that upside down, which is 3/7. So here's theta. Cosine is adjacent over the hypotenuse. And if I do Pythagorean theorem, I will find out that this side here will be square root of 40, which reduces to, I could break up that radical into 4 times square root of 10, which would be 2 square roots of 10, okay? So that's what that side is. Now, if I'm looking at this, what's the sine of theta? Well, the sine is the opposite over the hypotenuse. And therefore, the opposite is the 2 square roots of 10. The hypotenuse is a 7. And if I'm in quadrant 3, the sine is negative down there, okay? So that would be my answer for that, okay? Yeah. My other problem, my last one, another review, is the sine of theta equals -4/5, and I'm in the fourth quadrant. Find the cosine and the tangent. So I know in the fourth quadrant already that the cosine is positive and the tangent's negative. So I'm going to put those in there. Now I don't have to worry about those. And if I'm looking at this, theta, sine is opposite over hypotenuse. So I know that. And now if I did Pythagorean theorem, you would find the third side is 3. So now I can quickly fill those in. The cosine is the adjacent over the hypotenuse, which is 3/5. Tangent is opposite over adjacent. And there's my two answers. And I'm done. So that's it for today. Have a marvelous evening, and I'll see you all sometime soon.